In our first discussion, we talked about how scientists study the environment and how we learn about the environment and how things are affected in the environment. So today we're going to talk about what to do once we've done those studies. Now, when we do experiments or when we do correlation studies, we end up with a lot of data. And those numbers swimming around everywhere are useless unless we can organize it and make it make sense. Statistics is the process of collecting and organizing and classifying data, usually in number form, so that it makes more sense. So your grades at school is statistics, it's data. Your sports stats, how many RBIs are hidden, that can be a statistic and something that we do to understand and make it make sense. Are you doing well in school or not? Is that a good baseball player or not? Knowing that comes from looking at the statistics and the data. So when we compare data, when we organize it, we can organize data based off statistical populations. And statistical populations are groups of similar things that we're interested in learning about. So it could be the students that are in a classroom or the deer that live in East Texas. Although the population is composed of similar individuals, like all 11th grade students or all white-tailed deer in East Texas, they still have unique characteristics. Their weight is different, their height, their, in the case of deer, maybe their age. However, we can take a mean or an average and compare statistical populations based on that average. We can compare 11th grade students to 4th grade students. Doesn't mean that all the population of 11th graders are the same, but we can kind of get an average. They're usually 5 foot tall at least, whereas 4th graders might not be 5 foot tall. And you can find that average in your population. Once we have taken all of our numbers, all of our data, if we graph it, then we get some kind of pattern. And that pattern is our distribution. One common distribution that you may be familiar with is the bell curve. You may have talked about the bell curve when you talked about test grades. You know, some people may make 100 or 90, some may fail it, others are right there in the middle. With a bell-shaped curve, that indicates that stuff is grouped symmetrically around that average. You may take all the height of all the 11th graders. Some may be excessively tall, some may be excessively short, and then most of them are going to be about the same height, just a little bit above or below that. When we look at data, we may look at how likely it is to be that way, and that's probability. Probability is the chance that something will happen or that something will be a certain way. So for example, we could talk about the probability of a coin flip. What's the probability that a tossed penny will land on heads? If we toss one 10 times, it's possible that we could get heads 8 times and tails 2 times, but does that make the probability 80%? You know that's not true. Just because it can happen that way doesn't mean that the probability is exactly 80%. You have one head and one tail. It should be 50-50. We have a problem in this case with sample size. Our sample is not big enough. If you keep flipping that penny 100 times, then your number is going to get a lot closer to 50-50. So the sample size is how many objects or events that are sampled, and the bigger your sample size, the more that's sampled, then the more true your data is. So what a sample is, it's a group of individuals or a group of events or a group of trees or whatever it may be that are selected to represent the population. You obviously can't survey every single deer in East Texas. You can't survey every single coyote in Wyoming. But of that sample, of the ones that you do, you can get data based off that and then extrapolate that to the rest of the population. Now, an unwanted probability, the probability that something we don't want could happen, is risk. Most of the time when we talk about risk, you may be talking about insurance or driving safety, and most things that people consider is death, or the risk of death. And it's kind of funny to watch people overestimate the risk of something sensational, like being struck by lightning or a plane crash or a nuclear explosion, and underestimate the risk of things that are daily, that could happen, that do happen a lot more often. like smoking and drinking and car crashes, texting and driving. People tend to underestimate that and overestimate the possibility that you're going to get struck by lightning. The same is true for environmental studies. We tend to over-sensationalize environmental issues like nuclear meltdown and underestimate ordinary problems like pollution from a nearby factory. When we take our data and our statistics, we can put it together and model that data to help communicate those ideas. Models will represent those ideas, represent the system, represent the data. And we have four main types of models. We have physical, graphical, conceptual, and mathematical models. A physical model is something you can actually touch. It's a 3D model. So if you've ever done the project where you make an atom or a cell out of a tennis ball or out of a styrofoam ball, that's a physical model. You're showing what it looks like. A graphical model could be something like a chart or a map or a graph, a bar graph, a map like we see here. Those show a picture of the way things are laid out or the relationship between things. Conceptual models show how a system works or how a system is organized. So we have a food web right here. Those animals are not actually standing there. What you're doing is taking representation of those animals and showing how they're connected. If you've ever looked at maybe the instructions for how to put something together, like a model or an electronics or that IKEA furniture that you have to assemble, those pictures are a conceptual model of what things are supposed to look like and how they're supposed to go together. And finally, mathematical models. There could be equations that represent either how a system works or how a process works. So think about both a mathematical equation or a chemical formula. They show the relationship between variables. So it could be the equation for photosynthesis has how many carbons and oxygens and hydrogens and then what it creates on the other side. Okay, so we're going to stop there and we'll move on to section 3 next time.